Example 3. A wire 20 meters long is to be cut into two pieces. One piece will be shaped as a square and the other will be shaped as a circle. Part A. Express the total area A enclosed by the pieces of wire as a function of the length x of a side of a square. So we're looking for, eventually here, area as a function of x, A of x. Here's a picture of what we're talking about here. So here's this wire that's 20 meters long. They're going to make a cut right here into two pieces. They're going to take the first piece and make it into a square with side x. So if you have your square and it has a side of x, we know all the sides are the same in a square. So that's 4 x's altogether. So the length of this piece is going to be 4x. Then the remaining piece is going to be made into a circle. So if you started with a piece that was 20 meters long and you use up 4x of it for this smaller piece, then this other piece, you'll have 20 minus 4x left for this piece to make this circle. So the circumference of this circle is going to be 20 minus 4x. So the distance all the way around this circle is going to be 20 minus 4x. Okay, so if we want to express the total area of these two pieces, so our area, and I'll use subscripts here because we've got several areas we're talking about, the total area is going to consist of the area of the square plus the area of the circle. Well, we already know the area of the square is x times x squared. Length times width, or the side squared. And the area of a circle, recall your area of a circle formula, pi r squared. So remember, we want to get this eventually into a of x, meaning the only variables besides a we can have are x. So we're okay here, but we've got to change this r somehow into an expression with x. Okay, so let's back up. We know something about the circumference of this circle. 20 minus 4x is the circumference. So let's back up. Circumference, recall, our formula is 2 pi r. So we can substitute in here for our circumference, 20 minus 4x is our circumference in this case. Sorry, I forgot my x on here. Oh, and it's not 40x, it's 4x. So I can solve this expression now for r and substitute it back in here. So if I divide both sides by pi, or sorry, by 2 pi, I'll have, and we can reduce now over here, all these are divisible by 2, so I can divide out 2 here, divide 20 by 2 and get 10, divide 4x by 2 and get 2x. So that leaves me with 10 minus 2x over pi equals, and here our 2 pi's divided out, equals r. So now I have an expression here, 10 minus 2x over pi, that is in terms of x. So I can substitute this for my r, so then I'll have a function in terms of x. So I can fill in. Now I can say my area total is a of x, because it's in terms of x. So I've got my x squared plus pi. Now instead of the r, I'm going to substitute in 10 minus 2x over pi. So all I did was I took my new expression for r and substituted it in here, giving me this. So now I'll square here. So again, as we get into Math 1148, I'm encouraging you guys when you square a binomial to try to do that in your head. You can always write out 10 minus 2x times 10 minus 2x and multiply, distribute with FOIL. But I'm encouraging you to try to get in the habit of doing that in your head to save some time. So if I want to square 10 minus 2x, first I square 10 and get 100. Then I multiply 10 times negative 2x, so that's negative 20x, and then I double it, so that's minus 40x. And then I square my negative 2x, and I get 4x squared. So now I've got this fraction. I squared the numerator. Now I square the denominator. Well, pi squared, that's just pi squared. Now I can reduce my common factor of pi. That'll just give me a pi in the denominator. So my new simplified expression here will be x squared plus 100 minus 40x plus 4x squared over pi. This is my function a of x.